Hi everybody, welcome back for lesson 25-2, which is going to talk about inscribed angles. So we're going to talk about some relationships between an inscribed angle, central angles, and arcs, and then we're going to use those theorems and properties to solve some problems. So make sure you have your Springboard book open to page 353, something to write with, and a highlighter for some of those important parts. Okay. Now, we've already learned so far about central angles. Remember, a central angle is formed by two radii and join at the center of a circle. And we already know a little bit about them. So your book wanted you to use a ruler here, but I'm just going to say, make up a number. Say angle AOB, say we call that angle 40 degrees. Okay. Well, we know from our previous lesson that if we have a central angle opening up onto an arc, that those measurements are congruent. So that makes arc AB the same thing. Now, our new information here is what is called an inscribed angle. So an inscribed angle is an angle formed by two chords with a common endpoint. So again, this is the central angle because it's coming from the center, but an inscribed angle is formed by two chords meeting at an endpoint. So here's an example of a inscribed angle, angle A. Okay. Now there are two chords meeting at the common endpoint at point A. So inscribed angles also have a special relationship between the angle and the arc that it opens up onto. It's this arc here. So let's investigate that a little bit. I have a website where we're going to look at this. So here we have an angle CA or CDB and the arc that it's opening up onto, where your two endpoints meet. So this arc CB. So let's look at the angle here, our inscribed angle, and compare it to our arc. So we have 50-degree angle, 100-degree arc. Now let's say I change this angle a little bit. Let's say I make it 40. Okay, 42. Look at the arc, 84. Let's move this around even more. Maybe make it pretty big. Now this is kind of hard to see, but we have a 100-degree angle and a 200-degree arc. So what kind of relationship are you noticing between a inscribed angle and the arc that it opens up onto? Okay. Well, hopefully you're noticing that the inscribed angle is always going to be 1/2 the arc measure. So if CB, let's say CB was 100, then our arc would have to be half of that, or our angle would be half of that. So that would be 50 degrees. Okay. So that is our relationship here with inscribed angles and their arcs, which I think is on the next page here, question 7. Make a conjecture about the arc measure and the inscribed angle. Okay. The measure of the inscribed angle is 1/2 the arc angle, which, remember, the arc angle is the same thing as the central angle. So that's why I kind of put those side by side. But that's our first kind of theorem. The next theorem we're going to talk about before we fill in all these problems is a conjecture about the diameter of a circle. So let's look at what happens when we have inscribed angles and a diameter. Going back here. Okay. Now we've already learned little things about a diameter, and that when we have a diameter, because it goes from half the circle, we get a semicircle. Now we learned in a semicircle, those are always 180 degrees. So it makes sense that our inscribed angle here is 90. And again, it doesn't matter kind of how we change this problem. Anytime we have an inscribed angle opening up to a diameter, it's always going to be a right angle. Okay. Use that in our problems here at the bottom. Okay, so that's this conjecture down here. That inscribed angles on a diameter are right angles. So that inscribed angle will always equal 90 degrees. Okay. So let's do that. We're going to fill in these problems up here. So we're given circle C with diameter AR. Okay, remember, anytime we're given diameter, we're probably going to use the fact that that's a semicircle. But they gave us the measure of HCA. They say HCA is 50 degrees. Now, HCA is a central angle, so if I have a central angle, I also know that this arc, HA, is 50 degrees. And again, we were told that this is a diameter, so we have 180 degrees for the whole thing. So that makes arch here, HR has to be 130 then. So I'm just kind of using the given information to label what I can, and then let's fill in these problems here. So they want us to start by finding the measure of angle HIA. So let's see. HIA would be this angle. Okay, now this is an inscribed angle because the two chords are meeting at the end point of the circle, and it's opening up onto that arch HA. Now that arch is HA is 50, so that inscribed angle would be half of 50, or 25 degrees. My pen is not working. There we go. 25 degrees. Okay. Next, let's find the measure of angle HCR. HCR. Well, that's a central angle, and since I already found the measure of the arc, we know that those are congruent. Central angles are congruent to the arc that they are at, so that's 130. So I already did the work for that one, so that's good. Next, let's find the measure of angle HIR. So HIR would be this angle. Okay, now this would be an inscribed angle because the end point is at the circle here on the edge of the circle, opening up onto that arc that's 130. So we just have to take half of 130. That should give us our inscribed angle. So half of 130 is 65 degrees. Okay. Lastly, let's find the measure of angle AIR. I'm going to kind of erase this a little bit in the middle here so I can get a cleaner picture. So let's see. Next, they want us to find the measure of AIR. AIR. Now, this is an inscribed angle opening up to a diameter. Okay, and we know from our previous conjecture for letter E here, anytime we're opening up to a semicircle, that we have a right angle. So that one should be 90 degrees. Okay. So this problem kind of had a bunch of different theorems, talked about central angles from yesterday, and including those inscribed angles. Remember, central angles and arcs are congruent, but inscribed angles, the one the point is on the edge of the circle, and the arc are half. And then anytime you have something opening up to a diameter, it is a right angle. All right, let's move on to the last theorem that we're going to talk about today, and that's when we have an inscribed quadrilateral. So that's something that looks like this picture here. So say I have this circle, and we have inscribed quadrilateral, RUBY. Okay, so let's look at, now this proof I filled in for you, and you can look at that proof if you would like, but let me kind of show you instead a little demonstration here, and let's look at this quadrilateral. So we have a circle with an inscribed quadrilateral. Now I want you to look at the angles and see if you notice anything about the angles. And even if I move this around, okay, if I move those angles around, if I move these angles around, there is a particular pattern of something happening, and I want to know if you can figure it out. So something like this. Maybe I'll keep moving this. I'm moving this one. Okay, do you notice anything about the angles in this quadrilateral? Okay. Well, hopefully what I'm trying to get you to see is that the opposite angles are always summing to 180 degrees. Okay, so if we move this around, even if I move this around, okay, 70 and 110, 99 and 81, doesn't matter how we change this quadrilateral, what it is. Okay, our quadrilateral, this is going to be this conjecture down here. The opposite angles in that quad that are inscribed in a circle will always be supplementary. So they're always going to sum to 180 degrees. So we're going to practice some problems on the next page here. Actually, we're going to skip the next page and head to that check your understanding. Okay. So let's first start number 16. If an inscribed angle in a circle intercepts a semicircle, so an inscribed angle, let's draw this circle, opens up to a semicircle, so that means we're going through a diameter. So here's our inscribed angle. What do we know is true about the measure of our inscribed angle? So what does this angle have to be? And well, hopefully you know that means it's a right angle, okay? If our if our inscribed angle is opening up to a semicircle, that's 180 degrees, half of that will always be 90. So anytime we have an inscribed angle going to a diameter, it will always create a right angle for us. So that will probably help us solve some problems in the future. We'll have a right triangle there. Okay. All right, let's just finish up here with problem 17a. So refer to the circle O, where ABCD is an inscribed quadrilateral. Okay. AC is the diameter, and the measure of DAB is 122. So DAB, that's 122. There you go. So in 17a, they want you to find the measure of angle BCD. So BCD would be this angle. So that angle is 122. What does that make BCD? Okay. Well, that last property we just figured out was that the opposite angles in the quadrilateral should be supplementary. So 180 minus 122 should be 58. Okay. Now, how can we use what we learned in this lesson to prove that the sum of the measures of a quadrilateral in a circle is 360? Well, quadrilaterals have two pairs of opposite angles. If they both are added up to 180, add those together, we get a total sum of all four angles being 360. Okay. So again, we talked about three very important properties today. The first being that the measure, of an inscribed angle is always half the arc. That's our first one. Okay, the second one is anytime we have an inscribed angle opening up to a diameter, it will always be a right angle. And lastly, when we have a quadrilateral, the opposite angles will always be supplementary.